Hello guys, today in our Rockstar series we are going to look for potential in system of concentric shells, spherical conductor and some PYQs. Okay, so let's start the session. Here are the content: electric field and potential in charged shell, how to write electric field and potential in concentric shells, question of finding potential where the charge density is given, question involving earthing and question involving connecting the shells. Okay, now here one spherical shell is there, okay, having radius r, and the charge on the surface of this spherical shell is q. Okay, now when the r is less than r, that means this is small r which lies inside this spherical or concentric shell, that means point where we have to determine electric field or potential which is lies inside, then obviously the electric field inside this concentric shell is zero. Okay, but potential is kq upon r, and this potential remains constant from 0 to this r. You can see this graph also. Okay, the potential is remain constant from radius 0 to r, and then it start to decrease, whereas the electric field given by kq upon r square, okay, for this spherical shell, okay, is 0 up to the point r. Okay, on the surface it will be kq upon r square. On surface its value is kq upon r square. Okay, and after that it will also start decreasing. Okay, that means here you can see on the surface when r is equal to capital R, small r is equal to capital R, is equal to kq upon r square, and v is kq upon r, and after that suppose whatever is the point is here, we have to take that distance at the denominator. Okay, we have to take the distance at denominator. Okay, next, now how to write electric field and potential due to concentric shells. Now you can see here there are three concentric shells are there, okay, having radius r1, r2 and r3. Okay, now the q1 is the charge on a shell, innermost shell, then in between shell having charge minus q2, and outermost spherical shell have the q3 charge. Now our target is to determine the electric field and potential on the point A, B and C. So we have to write down the equation for electric potential and electric field on these respective points. Okay, now let us start. For the point A, because of this sphere 1, we can say having charge q1. Okay, now we this point A is lies inside this sphere 1 having charge q1, so we know the formula kq1 upon r1. Okay, from this center point up to this surface of the sphere 1, the potential remains constant kq1 upon r1. So any point here a1 is a point, a1 is there, or maybe more closer to this origin, then also we can write the equation kq1 upon r1 up to what, up to this surface, up to this surface having radius r1, you can write the potential is kq1 upon r1. Okay, now because of this q2, okay, because of this q2 you can write kq2 upon r2. Why? Because from this is the origin and q2 lies on the surface second having radius r2, having radius r2, that means from this 0 to r2, what is the potential because of the charge q2 is kq2 divided by the r2, and a is lies inside this r2. Now because of the q3 charge, okay, now point a is lies inside this q3 charge sphere also, so we can write kq3 upon r3. Now q2 is negative, that's why we have taken minus sign here. Okay, so kq3 upon r3, because from here, from 0 up to distance r3, the potential is kq3 upon r3. It's a constant. Okay. Now for the point B, for the point B, point B is the outer point for sphere 1 and sphere 2. Okay, sphere 1 and sphere 2, and for sphere 3, B is the inner side point or inner point. Okay, now for, because of the charge q1, the potential at point B, we can write kq1 upon distance rb. What is the rb? Rb is the distance from origin to up to the point B. Okay, up to the point B. That means you can draw a sphere passing or a concentric shell passing through this point B with radius rb. Okay, you can draw a concentric shell passing through this point B with radius rb. So similarly, for point B, the potential because of the q2 is kq2 upon rb, kq2 upon rb, and for q3 it's an inner point, so obviously kq3 upon r3 you can write. Okay, now for C is the outermost point for all the spheres or all the concentric shells, so you can write kq1 upon rc. You have to, this is 0 and this is C. From here to here distance is the rc. Okay, distance is rc. Okay, from this point C to here distance is rc, so you can write kq1 upon rc minus kq2 upon rc plus kq3 upon rc. Okay, up to that point, or you can assume from here to here you have taken distance rc and you have drawn one concentric shell, you have drawn one concentric shells. So this is the equation for the potential at point E, B and C. Okay, now at point A, electrical field is 0. Okay, it is inner point of all the sphere, inner point of all the sphere. For sphere 3, 2, 1, A is the inner point. Okay, so electrical field at point A is 0. You have to remember this concept. Electrical field at A, it is 0 because it is the innermost point for all the sphere or concentrations. Now for B, it is outermost point for sphere 1, sphere 2, but inner for q3. Okay, so only we have to consider sphere 1 and sphere 2 here. We can write kq1 upon rb square minus kq2 upon rb square. Okay, q3 के वजह से नहीं आएगा. Okay, at the point B there will be no electrical field because of the sphere 3. Then at point C, at point C it is the outermost point. Okay, so point C's net electrical field is because of all these three spheres S1, S2, S3. Okay, so we can write K upon RC square Q1 minus Q2 plus Q3. K upon RC square Q1 minus Q2 plus Q3. Okay, so now we understand that how to write the equation for electrical field and potential due to the concentric shell. Okay, next. Well, here is one numerical is there. Three concentric metal shells A, B, C of respective radii A, B, C. So A is less than B, B is less than C. So A is the innermost circle or spherical shell. B is a mediate in between B and in between A and C. Okay, having surface charge densities plus sigma minus sigma plus sigma respectively. That means for sphere 1 and sphere 3 is plus sigma same, and sphere 2 it is also same magnitude but in opposite direction. Okay, the potential of shell B is, हमें क्या करना है, B का जो surface पे potential होगा इसको हमें find out करना है. Okay, क्या करना पड़ेगा हमें, we have to first write down the charges like this q1 in terms of the density, charge density, because the option, if you observe the option here, all have the values of sigma, all contain the term sigma. So we can write q1 is equal to 4 pi, radius is a, r square we have to replace by a square into sigma q2 4 pi r square sigma 2, actually we can write minus here, q3 is equal to 4 pi c square sigma. So now at the point B, the equation of potential is, because of this sphere one is k q1 upon a square, k q1 upon, sorry, k q1 upon b minus k q2 upon b plus k q3 upon c. Okay, k q3 upon c. So now we can replace the values also. We can take here k upon b common, so we'll get q1 minus q2 plus here k q3 upon c. Okay, now what is the value of q1? 4 pi a square sigma. So sigma we have taken common. Now written here 4 pi a square minus 4 pi b square plus k 4 pi c square sigma upon c. Okay, now you can take 4 pi also common. So 4 pi sigma upon b into 4 pi epsilon. You can replace the value of k is 1 upon 4 pi epsilon naught. Okay, k is 1 upon 4 pi epsilon naught. So 4 pi get cancelled. In bracket what will remain? A square minus b square plus 4 pi is c square and c will cancel, and k is 1 upon 4 pi epsilon naught. So 4 pi will get cancelled. So sigma upon epsilon naught will be remain here, and one c is there. So sigma upon epsilon naught a square minus b square upon b plus c. So option number is C. Next, here the charge q is distributed over three concentric spherical shells of radius ABC such that their surface charge densities are equal to one another. The total potential at a point a distance r from their common center where r is less than a. तो यहाँ पे डायग्राम नहीं है. Here you can see the three concentric shells are there having the radius A, B, and C, and the point located is at a distance r which is less than a. That means it is located inside the innermost shell. Okay, it is located inside the innermost shell. Okay, now the total charge is q. It is distributed over all the three surfaces. Okay, total charge is q. It is distributed over three concentric spherical shells. So we can write q is equal to capital Q is equal to q1 plus q2 plus q3. Okay, now what is the q1 in terms of sigma 4 pi a square sigma, similarly q2 4 pi b square sigma, q3 4 pi c square sigma. Okay, now at point r we can write down the equation kq1 upon a plus kq2 upon b kq3 c, because that point, suppose we denote that point by capital R, that capital R lies inside for all the three concentric shells, for all three concentric shells. Now what we can take common here? We can take first k common, and we can replace the q1 q2 q3 by these values 4 pi a square sigma, 4 pi b square sigma, 4 pi c square sigma. Here a square by a, we can eliminate the square here, here also, and then we can take the 4 pi sigma common. Okay, if you take that common, what will remain inside? K 4 pi sigma a plus b plus c. Now total charge is q. Okay, total charge is q. For that we can write the equation like sigma into 4 pi, the total area, suppose 4 pi a square plus 4 pi b square plus 4 pi c square. We have taken 4 pi common, so a square plus b square plus c square remain in the bracket. So total surface charge density is q upon 4 pi a square plus b square, so c square is equal to sigma. Simply you have to replace this sigma surface charge density by this equation. Okay, what will be remain here? Q in bracket a plus b plus c upon 4 by epsilon naught a square plus b square plus sigma square. That is option number 4. Okay, next. Here in the figure shown, if the outer shell has a charge plus q and the inner shell is earth, then determine the charge on the inner shell and find the potential of the outer shell. Okay, यहाँ पे कंसेप्ट आपको याद रखना है क्या है। यहाँ पे outermost जो शेल है उसके ऊपर प्लस क्यू चार्ज है। ओके, एंड इनर जो शेल है उसको अर्थिंग किया हुआ है। जैसे आप इसको अर्थिंग दोगे, इसका पोटेंशियल जो है, इसका जो पोटेंशियल है वो क्या हो जाएगा? जीरो हो जाएगा। ओके, इसका जो पोटेंशियल है वो क्या हो जाएगा? जीरो हो जाएगा। Okay, so we can write this equation like, first of all, for this shell having a radius r1, what is the potential equation? Kq, okay, upon r1 plus kq2 upon r2 is equal to 0. Okay, यहाँ पे सबसे important key point क्या है? Whenever you given earthing to this inner shell, इसका जो चार्ज है become 0. Okay, the charge will become a 0. So now we can solve this. Kq1 upon r1 is equal to minus kq2 upon r2. It will lead kq1 is equal to minus q2 upon r1 upon r2. Now the charge on, now the potential on sphere S2. Okay, now the potential on sphere S2, we can write the equation K is q1 or q upon r2 plus kq upon r2. Okay, kq upon r2. So here we can write q1 is equal to minus q2 r1 upon r2. Here r2 is there, r2 is there, become r2 square plus q upon r2. Now you can take q as a common and 1 r2 as common. Okay, here minus sign is there. Okay, so here will be 1 is there plus 1 minus r1 and 1 r2 will be remain here when you take r2 common. So 1 minus r1 upon r2. Okay, 1 r2 is taken common, r2 will be remain here. Q upon r2 is taken common, so 1 will remain here. So plus 1 minus r1 upon r2 is the answer. So first what they ask, determine the charge on the inner shell. Inertial charge is q1 minus q2 into r1 upon r2, and find the potential of the outer shell. That is the answer is qk upon r2, 1 minus r2 r1 upon r2.